So this is a little 1 hour segment on tidy data. And last year we actually did it as part of the data visualization session, which we're going to have tomorrow. And it's still very, very closely related to that session. And you'll see why. So I work in bioinformatics. I deal mostly with genomic data or clinical data. So I don't, some people in bioinformatics do, but I don't deal a lot with, say, image data, for instance. And when I talk about tidy data, I'm specifically going to be talking about tabular data. So this kind of stuff you find in a database or a spreadsheet or a table of information, right? So I work with that kind of data all the time. Tables of information about genes or about patients or about experimental samples or what have you. And so I'll start by just telling you what I mean by tidy data. And I'll show you a little bit of functionality in pandas for dealing with tidy data, and I'll show you why you care. Specifically for plotting, we're going to care whether data is tidy or not. Can I just get a show of hands? How many people have used pandas? Okay, that's nearly everyone. Has anyone not used pandas? Because I can do a brief intro, like when we get into it. Okay, maybe I'll do a really brief thing. So it's not going to be a pandas lesson by any means, but I think it's probably intuitive enough that you'll see what's going on. And similarly, how many people have used Jupyter, like Jupyter Notebook, for instance? Okay, also nearly everyone. Excellent. That will make things much easier. Okay, so this is a quote from Finn's Buffalo: "Write code for humans, write data for computers." And writing code for humans, you may have heard before, it means you don't try to optimize every last breath out of your code. You try to make it readable, because in the long run, that probably saves more human hours than optimizing it down to the last bytes, right? You have comments and you have sensible variable names and things like that, and sensible code structure. But when people store data, especially if they're not from a computing background and they're sending you some data, so say a clinician is sending me some data, they will often put it in a spreadsheet in a way that makes a lot of sense to the person who looked at it and wrote it down, but is unparsable, and you just can't analyze. So tidy data means doing your data layout in such a way that you can actually write a program that uses the data without a ridiculous amount of work. And Hadley Wickham, who's really well known for his R work in particular, formalized some principles which I think are kind of common sense, but he wrote them down in a paper, to say that data is tidy if you put every variable, if you've got a table of data, if you put every variable in a column, so every variable corresponds to one and only one column, and every observation or sample, whatever that means for your data, into a row. And only your values into the cells. And this sounds simple, but I'll show you examples where it's not true. So those are those three principles written down. And exactly what you mean by observation type might depend on what data you're actually dealing with. There's a few other things you should try to do. You should try to mark missing data in a way that you can actually tell that it's missing data. Don't use 0 to represent a missing value, for instance, or -1 or something like that. So before we go on, I want to do a little... so here's an example of what... This is data is tidy, right? Satisfies the principles we just had. This is the iris data set. It's very commonly used as an example in statistics, especially. Every column here is a variable. Some of them are numeric, and this one is categorical, but they're all just one variable. And every row is an individual flower that was observed when they were doing this experiment. So what does untidy data look like? Here's some. So you can go to this URL if you want, but you don't have to, because I'm going to put it up on the screen. Let's make it big. And I might actually see if I can zoom in further. So given the sort of the principles I just described, I get data like this all the time. Like, not to do with house sales, obviously, but to do with genes or whatever. Yes. I get data like this or worse constantly. Can anyone tell me what's wrong? Like an example of something that is untidy about this spreadsheet?
You've got Latin long in the same column.
Yep. So it's like two variables in the same column.
Two tables with two different years.
Yep. So if you tried to parse that in as, say, CSV or something.
Dates are in inconsistent formats.
Yes. Dates are in inconsistent formats. And even worse, the first set of dates has no year. Although it's in the title, right? But it's not in the actual data. It's been put into the metadata instead of the data.
Got some units in that plot area.
Yep. So the area of the property here has square feet in it, which is no good if you're trying to parse a number. Really, if you wanted to record that, you should record it here, right? Or somewhere else completely if you want outside the table. But the sensible place in the table is in the name of the variable, if anywhere.
To be really picky, there's no shading for the Latin
Oh.
longs.
Are you a geosciences person?
Yes.
Yeah. Anything else? Yeah, so it's kind of, I guess, tied into the fact that there's two tables here and not just one big table. Is we've got our tables just placed in arbitrary places.
They could have just added another column here.
Yeah, that's right. There's no reason to have two tables here. These are not different kinds of observations. These are all observations of housing sales. There's no reason to have them in two tables, really. Yeah, between the two tables. And this is an ambiguous date format, right? Depending on if you're in the US or in Australia or England. So there are better date formats than that one, which are not ambiguous.
Bit inconsistent with the sale date, the sale price, so you've got none and then you've got a sale price of 0.
Yeah, so these zeros have been used to record missing data, which is bad. Like if I were to take the average sale price without noticing that someone had done that, obviously I'll get the wrong answer. Anything else? There's actually lots of things wrong with this. I can't think of many things that didn't do wrong with this, except possibly to use color to represent information, which is fine for humans, but not great if you're saving it to CSV and then reading it in again. Or symbols. I have received data where like a Chinese radical that looks like a tick mark was used to mean yes. And an empty space was used to mean no. Anything else? So we are. So there's one final thing, which is actually the kind of fundamental thing that I want to show you how to fix, because it's maybe less obvious than some of the other things, which is that we've got 2 sales per row, right? Up to 2. So some of these properties have been sold once, like this one, and some of them have been sold twice, like this one, and presumably none of them have been sold 3 times, because the schema we've set up to record the information wouldn't even hold that. And if this one were to be sold a 3rd time, we would have to change the shape of our table to hold that information. So this is what's often called wide form data, where different columns are used to represent sort of different values of the variable. Was this the first sale or the second sale or the 3rd sale? And in general, for tidy data, we shouldn't have that. We should have date is a variable, so date should be a column, not 2 columns. And price is a variable, so price should be a column, not 2 columns. Okay, so what I want you to do, and you've said like nearly everything, so it's probably easy now, but just with your computing partner, just with pen and paper, or if you don't have pen and paper, you can use a text file on your computer. Just sketch out, if you were to turn this into tidy data, what would your table or possibly tables look like? Like what would be the headings, what would be the tables and what would be the headings of those tables? The field names in those tables. And there's actually more than one right answer. Does anyone want to tell me what their answer looks like? Yeah?
There's 2 tables, one table for the sales,
Yeah.
and then hook up other 2 details in
Okay. Yep. And I know other people had what's probably the other main alternate solution, which is, what does your one look like?
Yeah, we have year in the first column, and then the unique property IDs, and then latitude, longitude separate. The other one's separate, move the units up, and then sale is just one column.
Yeah, okay. So there's kind of more than one right answer to this. And it depends on the purpose. It depends on how you're storing the data and for what purpose. So which version have I got as which? So one is to just do one big table, right? Which I think is probably what most people have done. So this is the same as the information I had before. I've actually got a sale ID, which is not an absolute necessity, but if you want a unique identifier, it can't be the property ID because each property was sold more than once. So, and it's a good idea to have a unique identifier. We've got units in the variable name, just as a place to put them that's not in the data, and everything is separated into separate variables. The other reasonable, yeah.
Column C there, sale number.
Yep.
That would be, that's sorted by date.
Yes,
Sort of
yes, exactly. So a lot of the time you probably wouldn't want this column at all, right? Because you can always calculate it by just counting the sales. So I only put it in because technically that information is there in the first table, and I was retaining all the information. But yeah, if you were designing this from scratch, you wouldn't record sale number unless there was some reason you really needed to know sale number. Yeah.
Is it not better to know sale number so you know which of your samples are dependent?
It depends. Well, you can always calculate it from the data. So if I gave you everything except that column, you could work out that column just by taking the property IDs and counting down. So it's sort of redundant information. I just kind of put it in there to illustrate all the information that was in the original table. I think of all the rest, it's not really redundant information. So this is a flat table, like one flat table, which is very convenient for analysis purposes and will work really well with plotting libraries. But one thing you might notice, and the reason some people came up with an alternate solution, is that we're actually storing the same information more than once, right? So we've got the living area of this property is stored 3 times, even though it's obviously going to be the same every time. So the other reasonable solution is sort of the relational database solution, where you have 2 different tables, and one of them just stores the information about properties, which is the information that doesn't vary property to property. And the other one stores the information about sales and just refers to the property ID like that in order to tell you, so that you can look up the information about the property. And if you are using SQL, you could obviously do a join between these tables if you needed to get the information. If you're using pandas, you can do a join or a merge as well. If you are doing plotting in particular, you would probably at some point want your data in this form, even if you need to do join or the merge to get it into that form. But if it's really big data, maybe you want to do that at the very last minute when you've sliced it and subset it. So both those answers are right, really. Yeah.
Another thing, yeah, I probably wouldn't have spaces between headers, 'cause
That's
then
true.
they're autocomplete.
It depends. Yeah. It depends what you're using, but it's a good principle not to have spaces in variable names. This is right. So there's one other form which is going to look odd, which is this form. And this is tidy, but it's weird. So I've still got the sale ID, but this is, so originally we had it in wide form, and then we put it into a longer form. So instead of having date 1 and date 2 and price 1 and price 2, we got those down so that now sale number is in a sense a variable instead of a part of the column name. And this is an even longer form. This is the longest form you could possibly get for your data. So here the only identifier is the sale ID, and then every variable is just recorded against the sale ID separately. And this does store the same information. It's not very easy to read. It's perfectly parsable, and it's not very commonly used, and it's not particularly good for plotting either. But it does have a conceptual use, which I'll show you when we get to the analysis. Yeah. Yeah, it's true.
So, like many databases from the government are in JSON format. There is any advantage besides the one that you have to mention in terms of the file size? Or?
No, I don't think so. If anything, this would take more room to store. Because now you've got this categorical variable, which is the variable name. Actually, it's probably quite similar as long as these variable names are being stored in a sensible way, like not as strings, then it's probably quite sensible still. But this is not usually used because the other tidy form is just as easy to consume, and one variable per column is more convenient to use for analysis. Okay, so what I want to do now so I have activated the Conda environment, but you shouldn't have to if you're on your laptops. I want you to check that you can launch Jupyter. So you can optionally use Jupyter Lab if you know it and you like it, but if you have no preference, probably just use Jupyter Notebook because it's slightly simpler, and I'll do the demo in that. Hopefully this works fine.
Should we get our repost note as well?
Ah, yes, sorry. The other thing you should do, so perhaps before you launch Jupyter Notebook, is you should clone a repository. There's notebooks in the repository, but I don't want you to use them because I'd rather you started from a blank slate, but there's data sets in the repository as well. So, so I'm actually going to change to another directory so that I can show you. Yep.
We haven't covered activating any source activate ASPP.
Will they need to?
Yeah.
Okay. I thought it was in the base environment on these machines. It is not. Okay. So you can do this before or after. These machines should already have a Conda environment called just ASPP, lowercase. I'm not on one of these machines, so I can't run that command.
Yeah, that does work.
Okay,
Yeah.
cool.
Can you probably increase the font size?
Yes. Ah. So I'll run it and get an error. That's fine. And clone that repository. Fortunately, you've done your Git workshop already. Sorry? Oh no, sorry, that's just what was on my screen already.
Should you clone the second?
Yes, no. Hang on. Let me remove all irrelevant things so it's less. So there's that, which will give me an error, but should not give you an error because you're on one of the machines. And there's this. Oh, my history. Okay.
Stop it.
Because I didn't actually execute that command, it's not in my history.
So where do we put it? It's not. Oh wait, what? So it's not template?
I will execute this command. And this repository I will fork into the ASPP general bundle of things, which will make it easier for you to find after the workshop. Okay, so is everyone, that worked okay for everyone? Everyone's happy? Okay. So what's in this are some notebooks, but we are not using them right now. They might be a reference for later, and in fact I'm going to update some of them because tomorrow's stuff is still last year's version of tomorrow's stuff. But the things we're going to use right now are these little CSV files. So just do Jupyter Notebook. And that's very tiny. And then let's make this bigger. So in Jupyter Notebook, do a new Python notebook, a new Python 3 notebook, which may be the only option. Oh, sorry. Here. Let me go.
We're having problems activating.
Ah. What happens when you try to activate it? Yeah. Yes. I don't know which version is on those laptops. Okay. Okay. So there is a notebook called Tidy Data in here, which will remind you of stuff later. If I think it's better to start from a blank notebook. You can use that one if you want. If you do, I suggest you make a copy of it, because I'm probably going to get you to Git pull tomorrow. And if you edit it, you'll need to stash the changes somewhere else. If that makes sense. Actually, it might be fine. Yeah. Oh, sorry, I'm just saying start a new notebook. So in your thing, just say new Python notebook. So I think everyone's comfortable with this environment, Jupyter. You've seen it before. If anyone is new to it, you can press H and get a list of commands. And you can find many good tutorials online to tell you about this environment. So check that you can import the libraries that we expect to be present. Sorry? Oh, yeah. Sure. Oh, sorry, I need to activate an environment as well. I switched windows to illustrate the Git clone, and then I didn't reactivate my environment. And my environment has a different name to yours. Actually, what I'll do is just switch to a window where it's activated.
Yeah.
So, where's my new one that I just made? It's probably not there. Doesn't really matter. Okay. Okay, so if the environment's working properly and Jupyter's working properly, you should be able to start it up and import libraries, right? And everything should work. And I'm going to do matplotlib inline so that we can illustrate some of our data with a plot if we want. So has anyone not used matplotlib ever? Okay. So we're going to do plotting tomorrow, but we'll do just some basic illustration today. So this command is a Jupyter magic, which causes the plots to appear in the notebook rather than being in a separate window. And it will work on any plotting library that uses matplotlib as the renderer, including matplotlib itself, obviously, but also Seaborn, which we'll look at tomorrow. And this is just importing the matplotlib pyplot module itself. So let me just illustrate. How many people have used pandas for melt and pivot? A much smaller number than have used pandas. Okay, so that's probably, sorry, for melt and pivot. Okay, so if anyone who's used pivot tables in spreadsheets is probably familiar with that concept of pivot. But either way, it doesn't matter. I'll show you. Basically, I think it is actually much clearer from what we just looked at than from some kind of spreadsheet analogy. Basically, melt is a command in pandas which was inherited sort of from R, which gets things from wide form to long form, and pivot is a command which gets things from long form to wide form. That's the short version. And I think if you talk to someone who's not used to programming but is used to spreadsheets, and you said pivot is for going from long form to wide form, they would look at you blankly, because that's not how it's usually thought of. It's thought of as a way to summarize your data. But that's actually the same thing. So let's see. Okay, so in this directory, I'm actually going to import C1 as well, because it's the fastest way to get a little data set. And then I'm going to you can follow along with this if you want. You don't necessarily have to. I'm just going to show you some commands. Oh, sorry. So that's just a handy way if you're online of getting hold of some example tabular data sets. So for the people who haven't seen pandas before, Iris is now an object called a data frame, which is a way of representing tabular data in the pandas library. I can look at the top few rows of that data frame using the head method, and you can see they're kind of what we were seeing before. I can look at the shape of that data frame. It's the number of rows and the number of columns. So there were 150 flowers observed in this data set, and there's 5 variables. Okay. Ah, sure. Hang on. Can I toggle the header? View. There we go. Excellent. And maybe the toolbar as well. Yeah, good idea. Let's have as much screen real estate as possible. Yep. So we're ending at 3, right, One? We need to end at 3 still. Yep, okay. So time is tight. Okay, so I'm going to show you a quick illustration and then let you try something. So this data is actually already tidy, but I'm just going to use it to illustrate some commands anyway. And then I'll give you one that's not tidy. So I said melt is a command for going from wide form to long form. So if I just do melt itself on this with no parameters, no arguments, this is what we get, right? So this is analogous to what I showed you before as the longest possible form for the data. Let's say head so we can see it. So that's what melt does. It goes from wide form to long form. I'm going to assign, I think we're slightly shorter of time than I thought. And I'm going to, so you may or may not know, reset index is a way of taking, actually let's do this first. Let's just do everything one step at a time. So now I've given it a meaningful index. This was the first flower we looked at, second flower we looked at. Reset index is a way of taking your index and turning it into a column. So now I have a column which is the unique identifier per row, which means I really don't need this index. And what I want to show you is if I melt, let's just have a look using the Jupyter help. Sorry. Melt takes a bunch of parameters. It takes ID vars, which are the variables that identify each sample in the data set. They're the ones you don't want to melt. Or alternatively, it takes value vars, which are the ones you do want to melt. So a lot of the time you want to specify one or the other of those. It also lets you specify variable name and value name. Col level is only used if you're dealing with multi-indexes, which I'm not really going to talk about today because there is not time. Variable name and value name, what they do is they set the names of these two columns here. Right, so here you can see when we melted it, we got a column called variable and a column called value. We could have called those something else. That's what those parameters to melt do. And in this case, those were sensible names, but sometimes they may be more sensible names for those. So for instance, if I want to melt iris, now that I've set this flower identifier column, what should ID vars be? Any suggestions? Index. Actually, I didn't give that column a sensible name, so I'm just going to have to call it index. I should really have given my index a name. Right, so in this case, that has not been turned into a value in the variable column. Right, it's been retained on each row. So I've got it into a long form, but not the longest possible form, which in many cases is what you want. So there's a little data set in this directory. I think we are not going to have time to do all the possible exercises. So what I might do is just leave you to look at the hard one. And we can talk about it tomorrow if people want to know the answer. But let's look first at the easy one. So if you load in the housing data wide.csv, actually you don't need to do head. This is a tiny toy data set so that you can see what you're doing. It's got 3 rows, right? So what this is a very, very cut down version of the example that we were looking at before, right? It's just got the property ID and it's got bedrooms, just as an example of keeping some information about the property, and it's got 2 prices. And I've dropped the dates to make this exercise, to make the first exercise easier. But it's still wide form because we've got 2 dates. So see if you can melt this into tidy data. In fact, I'm going to open this one. So if you look at the tidy data notebook after this workshop, you can find all the commands for loading these data sets in and the exercises that I'm telling you now so that you can easily have a look at them afterwards. Right, hang on. I'm not in Jupyter Labs, so I can't do that. So this is an exercise. See if you can get this little data set into tidy form. Alright, guys, I'm going to go through this. I'm going to go through a solution to this because I think we are getting very close to time for the next segment. And then I'll put up another exercise that you can optionally try before tomorrow. So I'm just going to do it on this sales-wide one. The basic thing we have to do in this case is melt. The basic problem with this data is that we've got a price 1 and a price 2. So the property ID column is fine, that's a variable. The bedrooms column is fine, that's a variable. But price 1 and price 2 are really the same variable. And so that's what melt is for. And this is a thing that caught out a few people, is that ID vars is, the name of it implies that it should only be the identifying variables, which is property ID, but actually it's any variable that you want to retain as a variable, right? So in our case, it really includes bedrooms because we don't really want to melt that down. price 1 and price 2 are the only ones that are not legitimately already good variables in our table. So I can give it a list of variables. And it would be equivalent if I said value vars is price 1 and price 2. You just have to tell it what to melt and what not to melt. So this is sort of tidy, right? It's not perfect, but it's sort of tidy. One thing we could do is we could use the value name, because in this case all our values are actually prices. So we could set the value name to be price, and now we've got a price column, which sort of makes sense.
And can you use variable name to change that?
Yeah. So I could set this to something like, so depending on what you're actually going to use this for, you may or may not want to actually keep this column. Like we may want to do this and then drop it. But if, assuming you do want to keep it, it could probably have a better name. Like maybe which price is this, or sale number or something. Right. So that's sort of tidy. The only thing really left that's wrong with it is that we've got these null rows where a property did not have a second sale, but we've just got an empty row because we came from a form where everything was assumed to have a second sale. So there is a drop in A in pandas, which would get rid of these. You can say drop in A any. I'm actually going to show you the other way because I think it's slightly more general knowledge if you don't already know both ways. So I'm going to use lock. So in pandas, I think nearly everyone said they'd used it before, but not everyone. There's two ways of indexing and slicing. One is with .lock, which uses the index and the column names to represent rows and columns. The other is with .ilock, which just uses the numbers. So it's always a number. This is row 0, this is column 0, etc., to represent rows and columns. And these things can also take Boolean filters. So in this case, the useful Boolean filter for us is whether the price is a null value. What did I just do? Oh, right. I didn't actually assign this to a variable. That's what I did. Right. So this is showing me just the rows where the price is null, and the syntax for the not operator we have to use the logical not operator for technical reasons when we're doing indexing. So we actually want the rows where it is not null, and we want all the columns. And that's, oh, sorry, melted, not tidy. There we go. So that's tidy, right? And you may want to drop that sale num column if you don't need it. But I'll leave it there for now. So any questions about that process? I'm going to just put up, you'll see in the Tidy Data Notebook there's another thing called white2, which has date 1 and price 1, and date 2 and price 2. If you try to carry out exactly the same exercise on white2, try to get it into tidy form, you'll find it is much harder. Because melting a thing which has one variable that's wide form is kind of conceptually not too hard to get your head around. Melting a thing that has two variables as wide form requires some pandas knowledge to figure out a solution. So if you're new to pandas, it's probably too hard. If you have been using pandas for a while, then have a go and see what you think. And I'll show you at the start of the plotting one, because we need to wrap up now for the next session. Yes?
You probably know the answer. I don't know the answer. Is it possible to do it in 2 steps? Only melt one and melt the other?
I think you need more than one step. Oh, right, sorry. No, so I would melt. So actually, I'll give you a hint. There's more than one way to do this, and there's ways that involve multi-indexes and things, which I find harder than the way I would suggest doing it. The way you probably want to do it is to melt down to very long form and then pivot to get back what you want with some manipulation in the middle. And I'll just show you briefly, where are we? So some people will not have actually seen the pivot command. So down here we melted iris. What if I say, sorry, now I'm going over time. Right, so what pivot does is essentially the opposite of melt. So if I say melted.pivot, there's two things, there's pivot and there's pivot table, and look at the documentation, because I don't have time to explain the difference, but pivot, we say we want to make a new table where the index is given by this index column in melted, and where the columns are given by the various values of the variable column. And the values come from what's currently the values column. It's quite simple since we melted to get here in the first place. And hopefully, what did I do? Did I do something silly?
No, it's because I think when you assigned that you had a head. Yeah.
Oh, right, sorry, yeah. It's because I had the head. Right, so that gives us back our original data set, except that as you can see, the flower column has been turned into an actual index, so we would need to do reset index if we wanted to get it back to the exact form we had before. Okay, so that's what pivot does. It's sort of the opposite of melt. There's also pivot table, which is slightly more flexible, and I think you need both to solve the second problem.
Thank you, Claire.
We're going to move on.
If you have questions, Claire's going to be around. You probably also
I'm around the whole week, yeah.
Yeah, the whole week. She'll probably also pick up some of these concepts again for the data visualization topic tomorrow. But we want to get into